here's a quick overview of just the hardware setup on my little experiment. I did a previous video on just a demo of how this works with closed loop velocity control. I have a TNC4 connected to a Simplefoc Mini with essentially a rotary encoder here to be able to adjust things like speed or angle. I have an AMT 103 encoder, and then I have a brushless DC motor. This is an 11-pole DC motor from Power Motors. I got this from AliExpress for about, I think $40, including shipping. To attach the encoder to the motor, what I did is I made a 3D printed mount with a shaft that goes all the way through the motor. This motor has a hollow shaft. That shaft goes all the way through the motor and connects to the encoder. The important thing is to minimize slippage between the shaft and the encoder. So it's a rigid shaft that then mates with the encoder sleeve. When you order this encoder, you'll actually see that it actually comes with a sleeve that is a setup that allows it to mate with any diameter shaft, but I actually found that that sleeve can cause some slippage, so I made this kind of solution here. The 3D printed files for these I can make available online. So yeah, that's essentially my hardware setup. For the encoders and the Simplefoc Mini, I'm drawing power from the 3-volt and 5-volt logic levels from the TNC. One of the great things about the TNC is every pin is PWM, and the interrupt capability of the TNC is really, really great. It's a very powerful microcontroller. Also great for just general purpose applications outside of motion control. And so that's why, for now, this is kind of what I'm using. You can also see that it's a fairly small microcontroller, which I enjoy as well. So the next test that I'm going to be doing, as I mentioned, is closed loop angle control, and so I will do a follow-up video on that. Thanks for watching.